Hello, I'm Paul Beckwith with the University of Ottawa Laboratory for Paleoclimatology, and I'm talking about very rapid climate changes and why we need to declare a global climate emergency. Just got the lights. So I just explained that in February of 2016, in part 2 of the video series, I explained that in February 2016, we were 1.35 degrees Celsius above this baseline, 1951 to 1980. When you take it relative to pre-industrial, it was actually much, much higher. You need to add and so according, the differences between the 51 to 80 average and the 1880 to 1910 average, and then add the difference between this to 1750 pre-industrial. And this number is actually 0.3 here, so that gives you 1.95 degrees Celsius. So the month of February was almost at that 2-degree window of safety that's talked about in all the global climate change conferences. So it wasn't just February. This is showing March, and you could see. Let me come back. This is showing March, and you can see that it's all these different months where the temperature is rising. This is Japanese data. Hopefully the US data, whatever happens in the US, we still have the public access to all of this data I'm using. This curve here is from a Japanese satellite, Japanese data, but most of the data in this presentation is from US satellites. So imagine a worst case scenario where we have a denier, chopping all of this and saying, oh, none of this data is accessible to the public anymore. That would be catastrophic, just when we need it the most. Okay, so all of these very warm temperatures in the Arctic are wreaking havoc on reformation of the sea ice. So this red line is showing what observations have done. In general, it's not updated for the last few years, which are lower. But the key thing is the black line is all of the different IPCC models, 20 plus global circulation models, including atmospheric AOGCMs, atmospheric ocean global circulation models that the IPCC is using, and they generate these curves, and this is the spread of all the models. So these models are completely under predicting what is happening with the sea ice. So this is showing the September minimum ice volume over the satellite era from about 1979 on. So you can see this is you can do all kinds of different fits to this curve. Some of them extend out. A lot of them come to zero shortly after 2020. So say 2022 or so. It's not just the September ice that's decreasing. The different colors are all different months. So September is the green one here. August is the pink one there, and October is the purple one here. So there and so on. So each month is dropping in average. This is volume of ice, exponential trends on them. Each month is dropping down more and more. And in fact, the months bracketing September, like this year, for example, October and November are going to be very, very low compared to, they're going to have much sharper drops in even September. And I'll show why. So very, very soon we're going to be losing sea ice completely in a summer melt and having what I call a blue ocean event. So there's the minimum in September. It happened September 8th, which surprised everybody because people thought it would be tracking lower. Normally it's about mid-September, the 15th or so, and we have the sea ice minimum. So the blue line is this year, and the dashed line is 2012. This is the mean, with 2 standard deviations being the gray area. So look what happened here. The growth of the sea ice this year has completely stalled out. It's still going up, but it's well below where it's been, where it should be. So what else is happening? This is the Arctic temperature above latitude 80 degrees north for 2016, the red line, compared to the long-term average, the green line. Look what we have here. This is November 13th. The temperature is about 17 degrees Celsius above average. What this means is in the Arctic, it's still basically, we're getting summer temperatures in the Arctic in November. This is extremely worrying, and in fact, if you look at the data from one more day, November 14th, which I don't have on my presentation, this comes up even higher. So the system is broken. The Arctic is clearly broken. There's nothing normal about what is happening in the Arctic. This should be making headlines in every newspaper around the world because it affects all of the extreme weather patterns. It affects how we grow food. Food yields are dropping around the world in a frightening amount. I'm talking about grains, I'm talking about rice, I'm talking about soy, I'm talking about staples that we have. These things are under tremendous stress from these extreme weather events, from heat waves, too much water, too little water, right? All we need is a simultaneous failure of these and food prices will spike. They'll double or triple or quadruple in price, and then we'll have people out on the streets protesting this. This is to be expected. It's just a matter of time. So this is extremely, if this isn't a climate change emergency, I don't know what is. Sorry, I can't put this in a rosy, pleasant fashion. This is the reality of the situation, whether we like it or not. So what are we going to do about it? Well, we voted, I didn't. In my friendly neighbors to the south voted in Trump. So we'll see what his climate policies are like. So this is the Antarctic sea ice extent. So not just in the Arctic, we're not just having really low sea ice formation in the Arctic, but we're getting this weather weirding or very unusual patterns occurring also in Antarctica. So in 2014, we had record sea ice around Antarctica, the green dashed line. This year, we have record minimum, and it's still pulling away from the mean, the black curve, and the standard deviation curves. So if you combine if you look at the total sea ice on the planet, this is a striking home run, if you like, of graph. All of these different colors are different years. We're going from January through the end of December here in 1 year. So the total sea ice area, adding the area in the Arctic to the area in Antarctic, gives you this. Well, sorry, but the red pen slipped and fell down here. You know, we're not getting this peak here. It's like what, 10 standard deviations below what it should be? This should be frightening. This should be concerning. What are the implications of this? Obviously, there's less sea ice, so we're having a darker, the planet is much darker. It's much darker in terms of human psychology on what's happening. It's darker. The albedo is lower. It's absorbing more sunlight, reflecting less sunlight, causing a strong warming feedback. So you can get up-to-the-date daily information on sea ice concentration, thickness, and ice movement from the U.S. Navy. So this is data from just a few days ago in mid-November. So this is the Arctic sea ice thickness. So the only thick ice is butted against the Canadian archipelago. This ice here, all this purple ice, is less than 1 meter thick. The blue is about 1 meter thick. So the only thicker ice is up in this region, and there's still lots of export of thicker ice through the Fram Strait. And the water is super warm here and super warm here. So when the ice extent tries to expand, it melts out into the water. It does cool the surface water, but there's lots of wave action, which mixes the surface water with water below. Unfortunately, the water below, even down 50 meters or so to the continental shelf, is much warmer than normal. Even 5 to 7 degrees warmer is what, according to Peter Wadhams, as he's outlined in his book, A Farewell to Sea Ice, which just came out September 1st of 2016. So basically, the ice is trapped amongst, it's the only cold thing trapped amongst the relentlessly warmer oceans around, which are just cutting it off and not letting it expand as much. This is the ice concentration here, and this is the movement of the ice. So the winds are, in this case, the winds are, normally you get the circulation being this way, the Beaufort Gyre, and then you get the transpolar drift. So the ice, normally you get that pattern, but this is opposite here. This is opposite here. We get very strong motion of the ice being dragged by the wind over in this direction. So this is very conducive to keeping the ice weak, thin and weak. Scenario, the overall trend continues. There's a high probability that the first blue ocean event will occur just after 2020. Okay, just look at the trend on the graph. So there'll be an ice-free duration, would likely be less than about a month in September for the first blue ocean event, say 2022. This ice-free duration would extend to 3 months within 1 or 2 years. So by 2023 or 24, we can expect a blue ocean in August, September, and October. And then we can add on July and November to the ice-free duration by 2025. And then by 2030 or so, we have ice-free Arctic Ocean year-round. And we're in a different climate. We'll have gone through an abrupt climate change. Global temperatures will be much higher because all that water is absorbing energy. This is an enormous feedback. The quantity of heat, latent heat, that's sufficient to melt 1 kilogram of ice at just below freezing point to 1 kilogram of water at just above freezing point. That amount of energy applied to that water above zero would raise that 1 kilogram of water to 80 degrees Celsius. Think of it this way. Do this experiment at home if you don't believe me. Take a kilogram, take a quantity of ice, weigh it. Take an equivalent quantity of water at 0 degrees, at 80 degrees, heat it up with the kettle to 80 degrees Celsius. Put that unit of ice, 1 kilogram of ice, into that 1 kilogram of water at 80 degrees Celsius, or whatever mass you use. What will the final temperature be of the 2 kilograms of water that ends up? Okay, most people will say 40, but unfortunately it's 0 degrees. All that heat in that water, kilogram of water at 80 Celsius, is all required to just melt that kilogram of ice, leaving the whole mixture at 0. Just try this experiment. So what this means is when there's no sea ice in the Arctic, the water temperatures are going to spiral up. This is going to perforate the ocean floor even more and thaw it out, and we're going to get a large increase in methane, and then we're going to be rocketing up to a much warmer temperature. You know, it's easy to consider 5 or 6 degrees Celsius rise in temperature in a decade or two at most, the way this system is going. Are we going to allow this to happen? Can civilization withstand this rapid rate? Can flora and fauna around the planet withstand this? Can we keep growing our population? These are all questions that should have been in the US presidential debates. Not some email, not some affair, cheating, whatever. These are the issues that are of fundamental importance to every human on this planet. And yet, for all the wonderful brains that we have and intelligence and wisdom and technology, we go and we talk about the idiotic things in important elections and not what's really important to humanity. So let's go to the next slide, and I'm going to have to continue this on to the next video. So thank you.